Now in this class we are going to discuss about the phosphorus. You know that the phosphorus occurs in minerals like the family of apatite, the fluoroapatite, chloroapatite, phosphorite and redonda, that is aluminum phosphate. So we write that minerals, then phosphorus shows allotropy. It exists as the white phosphorus, the red phosphorus and the black phosphorus. Thermodynamically maximum stable phosphorus is the black phosphorus, but the black phosphorus is formed from the white phosphorus as well as the red phosphorus. So when they are heated at high temperature, then those phosphorus, that is the white and the red phosphorus, are converted into the different form of black phosphorus, that is alpha phosphorus and the beta phosphorus. So we'll check that how that we are going to tell about the properties of white and red phosphorus, because red phosphorus is highly stable. It is not reactive easily, but the white phosphorus is highly reactive because of its structure in which there is an angle stream. So we'll check that how we are going to write the right information about the phosphorus. So let us check that what are the minerals in which the phosphorus exists. So we'll write that the minerals. So I'm going to write the occurrence. So minerals of phosphorus. That is, we can write that, I write that as, that is phosphorite. The phosphorite is a mineral of phosphorus, that is calcium phosphate, we used to say that. Then we used to write that the apatite family, that is, we say that it is fluoroapatite. The fluoroapatite will be like this, that is, we already know that, we have discussed about that fluoroapatite in calcium as well as in that, we'll say that the fluoroapatite like that is Ca3PO4 whole twice. Again we can write that. This is thrice dot, we can write that CaF2, that is called fluoroapatite. Similarly, I can write that is, or you can write like this, it is one and the same thing. You can write that apatite like this, that is 9, calcium 9, and this will be 6. You can write like this, that is a fluoroapatite. Similarly, if I write that this in place of that fluorine, if I write chlorine, it is called chloroapatite. So I can write that chloroapatite. Apatite we can write like this, that is Ca9PO4 whole 6 and dot CaCl2, that is chloroapatite. Similarly, I can write that redonda phosphate, that is aluminum phosphate. The aluminum phosphate, it is also the mineral of phosphate, that is called redonda phosphate. So redonda phosphate, right? Phosphate, that is also the right, that is the mineral of phosphorus. Now what we used to say is the types of generally the allotropes of phosphorus are alpha, that is black phosphorus is alpha. The allotropes of red, white and black. Black will exist as alpha as well as beta. So let us check how we can get that. The allotropes of phosphorus. So we are going to write that allotropes of phosphorus. So if I write that, I write that it is white phosphorus, then it is red phosphorus and black phosphorus. We'll say that. So that is the allotropes of phosphorus. Then we can write that it is due to its inability to form pi-pi bond, due to its inability to form the pi-pi bonds. It exists with phosphorus single bond. So it exists as, we'll say that it exists as, that is phosphorus single bonds. We used to write that, right? Single bonds. So it will have all the phosphorus, either it is red or black or it is white, they exist in the phosphorus structure that is having a single bonds. because of its inability to form the pi bonds as in case of nitrogen is. So we can write that it is that the allotrope is mainly the red and white phosphorus exist in nature, but the black phosphorus is thermodynamically maximum stable. So in this case, we'll say that the red phosphorus, that is the black phosphorus is thermodynamically maximum stable. So black phosphorus has maximum stability. Phosphorus is thermodynamically maximum stable. We'll say that is thermodynamically. We'll say that dynamically that is maximum stable. So maximum stable because of its structure, is in that is a hexagonal, that is rings. So we'll say that hexagonal sheets, maximum stable. We'll write that. It is like that. So that is the allotropes. We can write that. Now we can discuss about the properties of red and white phosphorus, because these are the two main phosphorus which exist in nature. So we'll discuss about the properties of these two phosphorus. So we'll write that the properties of the white and red phosphorus. So if we discuss the properties of the black, that is white and red phosphorus, that is write that red phosphorus. So we can say that because white phosphorus, which is more reactive than red phosphorus. So let us write few properties of that, so that we are able to compare between the white and red phosphorus. So we'll write that. If it is like this, that is we are going to write that it is the white phosphorus and the red. We'll first write that. We'll make a table for that. Right? We'll not write in that like that, no? In theoretical form. We'll make a table for that. So if I write the property, what is the property we are going to discuss? That is, we can also write the serial number like this. The number for the properties, how many properties we are going to discuss. Then we can write that property, and we can write that the white phosphorus and the red phosphorus is. So white, and I'll write that it is red phosphorus, like that we can discuss about the phosphoruses. So let us write few properties about that, the red phosphorus and the white phosphoruses. So the red and white phosphorus, we'll write that in this case, that is, we can write that the red phosphorus. So if we write that the occurrence of this, in occurrence, I can write that it occurs as a discrete molecule P4, but it occurs as a polymeric molecule. So it occurs as in form of polymer molecule, but this exists as the, right? We can say that the discrete molecule P4 is a discrete molecule which exists is. Next property we can write that is, we'll write its physical state. So if I write its physical state, I'll write that physical state that this is soft and waxy. So soft waxy solid, we will say that. And this is a brittle solid. So this will exist as a brittle solid, we will say that. So it will be a brittle solid. I write like this, that is brittle solid. So it exists like that. Next property we can write is, that is the order. So if we write about the order of this, then this will have a garlic order. So it will have a garlic order, we can say that. And that is the white red phosphorus, which is less reactive, as orderless. So this is orderless. This is orderless, and then we can write that it's that is, we are able to write that. If we talk about the melting point, what is the melting point for that? So I'll write that the melting point of this white phosphorus is only 44 degrees centigrade, but this sublimates at around 290, that is degree centigrade. So it sublimates at around 290 degrees centigrade. So that is how. So it sublimates at 290. That's right, room temperature. It doesn't have any order, but it will have, because the temperature is not very high. It will be, that is nearly, that is around the room temperature. That is almost, we can say that a few degrees that is higher than the room temperature. So it will have a garlic order. Next we can write is, the next property we can say is the solubility in CS2. So we write that solubility in water. Will say, if I write that solubility in water, so I'll write that the solubility in water, both are insoluble in water. So this is insoluble, that is also insoluble in water. Both are insoluble in water. So both are insoluble in water, but if I write that the solubility in carbon disulfide, so the solubility in carbon disulfide, that is CS2, this is soluble, but that is insoluble. So this is soluble in carbon disulfide, that is insoluble in carbon disulfide also. Because of stability, we'll say that that is more stable. I'm writing that. So this is more stable and this is less stable. So due to the stability, we are writing that like this. So this is less stable, that is more stable. That can also be one of the property. We can write that the stability, but due to the more stability, it is the properties are like this. Next we can write is that is a reaction with NaOH. So if I write that the reaction with NaOH, some of the chemical reaction we can say that reaction with NaOH it will produce reaction with NaOH, that is aqueous NaOH we are talking about. This will liberate phosphine gas, whereas in this case there will be no reaction. There is no reaction, but it reacts with concentrated nitric acid. So we'll write that the reaction with concentrated nitric acid, you can write like this. The reaction with concentrated HNO3. So with concentrated HNO3, that both will form, that is H3PO4. So both are going to form phosphoric acid. This also form phosphoric acid like this. Then we can write that the properties like that. We are going to write the phosphorescence property. So if I write that phosphorescence property, we can write like this. That is the phosphorescence property. So we'll write that phosphorescence property. It glows in dark. So it glows in dark, whereas this doesn't glow. Do not glow in dark. Do not glow. So like that we can write the property. Next property we can say that if required we can say that is a phosphorescence property. Then we can write that the reaction with air. So we can write that the reaction with air, both will be reacting with air when it is heated. A reaction with we can say that air, both will react with air at high temperature, and it will be both are going to form, that is P4O10. When they reacted with air, both will form the P4O10. So these are the properties of the white and the red phosphorus, you can say that. So if you write the structure of these, the structures of, we can write that the structure of phosphorus. So phosphorus, we can write that. Now if I write that the structure of phosphorus, we can write that the black, that is the white phosphorus, the red phosphorus, and the black phosphorus, we can say that. So these are structure, I can write that. So its structure is like this. It exists as a P4 molecule. So it exists as a discrete P4 molecule, but discrete molecule, I can write that molecule, but this exists as a polymeric molecule. So we'll write that the discrete molecule is like this. That is a phosphorus. You can write like this. The structure of this phosphorus can be written like this. So you can say that each phosphorus should form 3 bonds. So and having lone pair on those. So these are having a lone pair, as well as they are going to form the 3 bond with each other. So this is the structure of this. But these bond angles which are present here, you can write that these bond angles, all the bond angles are 60 degree. So all the bond angles are 60 degrees there. So you can check that how many 60 degree bond angles are present there. It is 3 60 degree bond angle with one of the phosphorus. Then 12 60 degree bond angles are present in that. So 12 60 degree bond angle in overall P4 molecule are present in that. So we can write that it is like this. Red phosphorus we can write like this. That is a polymeric phosphorus. So I'll write like this. That is a polymeric phosphorus. Then you can write that it is like this. The polymeric phosphorus is, so it is that polymeric phosphorus. Now I can write like this also. So these two, because this has a 3 bonds, so I'll write that it is like this. That is a polymeric phosphorus of red phosphorus. Now if I write the black phosphorus will be like this. I'll write the black phosphorus like this. Now this is, we know that the polymeric phosphorus is, so the polymeric phosphorus we used to write like this is the polymeric phosphorus. Now if I write the black phosphorus is like this. That is, we used to say that it is a hexagonal sheets like graphite. So hexagonal sheets you can write like this. That is phosphorus like this. The black phosphorus is existing in a hexagonal sheets. So instead of carbon, the cyclohexane we used to write that instead of carbon you write just the phosphorus. To get the structure of black phosphorus, we'll write like this. So this will be the structure of black phosphorus. I'm going to write that. That is how we'll get that the black phosphorus is. So these are the black phosphorus we can write. So this is the structure of black phosphorus. I'll write that. So this will be the structure of black phosphorus. So this is how we used to write the structure of the phosphorus are the black phosphorus, the white phosphorus, and we can write that red phosphorus. Red phosphorus is in polymeric form. We say that. So that is about that the phosphorus is. Now we know that the red phosphorus it is having that is the black phosphorus. We've written that that is non-poisonous, but this is poisonous, and this is non-poisonous. That is having grey iron type that is luster and has grey iron luster. Right? So that is how that is iron grey luster. Whereas the white phosphorus is that is poisonous and we know that it is insoluble in water. So that is how we are able to write that. And the white phosphorus it liberate that phosphine by reaction with that is NaOH. So if I write that we can say that the reaction of P4 with NaOH will be like this. That is we can write that it is like this. P4 that is a white phosphorus. P4 white phosphorus we used to say that it reacts with NaOH and we say that it is water to get converted into pH3 plus we'll write that Na that is H2PO2. So that is formed in the reaction. So we can write that the phosphorus that is 4 we'll get that Na, so we'll get H2 and we'll get that 4 pH3. So 12H we'll write that it is thrice. This will be thrice, we'll get that. And that is how we are able to write the reaction in this case is. And the water molecule is also required is thrice. So that is how the phosphorus, the reaction of white phosphorus with NaOH is to liberate the phosphine. So we used to write the reaction like this, how that phosphine is liberated. And this is one of the method, the lab method for the preparation of phosphine is. So that is how we are able to write that. Then we'll say that the red phosphorus when it is heated at high temperature. So we say that when the red phosphorus is heated at high temperature, it converts into the black phosphorus. Also, when a red phosphorus, we also say that when the red P that is heated at high temperature, that is 803 Kelvin, then in that case it converts into the black phosphorus. So black phosphorus. So it gets converted into the black phosphorus, that is phosphorus. The red phosphorus, when it is heated, it gets converted into the red phosphorus. So we get that red phosphorus like that. So when it is, and even the white phosphorus, when it is heated at high temperature around 573 Kelvin for several days in the atmosphere of CO2, then it will get converted into the red phosphorus. So like that we can prepare the black phosphoruses. So now we can write that preparation part, how they are going to be prepared. We can write that part. So this is what we say that is about the structure of phosphorus and their right properties of phosphorus. Now we can say that what are the right. We'll discuss something about some part about the black phosphorus. So I'm going to discuss few part about the black phosphorus is how we are going to discuss the black phosphorus. So if we discuss about the black phosphorus, we'll say that the black phosphorus, so it is formed. So I'll write that formation is formation by a red, that is white and red phosphorus, white and a red phosphorus. So I'll write that red phosphorus. So we can write like this, that is about the black phosphorus. When the red phosphorus is heated, so the red phosphorus is heated at, we'll say that 803 Kelvin. 803 Kelvin, we get that it is alpha black phosphorus. alpha black phosphorus. And so when we'll say that the white phosphorus when it is heated not at very high temperature but at around 473 Kelvin. So 473 Kelvin, it gets converted into the beta black phosphorus. Black phosphorus, we just write like this. Even when we say that, we can write like this. No, we can write that it is the red. How the red phosphorus can be prepared. So we can write that the white phosphorus, that is P4, that is a white phosphorus. It is a discrete molecule. So white phosphorus, when it is heated for several days, in the atmosphere of CO2, in atmosphere of CO2 at 573 Kelvin, we used to say that, then we get that a polymeric phosphorus, red phosphorus. Polymeric phosphorus is formed. That is a red phosphorus. So that is what we get after heating for several days. So we can write like this. That is how we get that. So that is about, we have just written that how we can form a red phosphorus also. Even from the white phosphorus, we can get the red phosphorus. From the red phosphorus, we get that it is the black phosphorus. And even from red phosphorus directly, we can get that is black phosphorus. So this is about that black phosphorus. We can say that is sublimized in air and have so the black phosphorus sublimise in air, right, and has a PQ, that is structure. We say that, and have a PQ, that is monoclinic or rhombohedral structure. Monoclinic or rhombohedral. We can write that it is a monoclinic structure. We can say that. Sometimes it is right like that. That is rhombohedral structure is. You must know that the monoclinic structure, rhombohedral structure, right now, they also exist in different right now, that is crystal form. So monoclinic or rhombohedral structure, and that does not oxidize in air. It is stable, so doesn't oxidize in air because thermodynamically it is stable. So oxidize in air. So that is thermodynamically more stable. It is thermodynamically more stable. Thermodynamically stable. So it doesn't oxidize in air very easily, and it does not burn in air up to 673 Kelvin. It doesn't burn in air up to 673 Kelvin. That is 400 degrees centigrade. So it doesn't burn in air. It is maximum stable. It has a hexagonal shape, that is hexagonal rings. It is an hexagonal rings or sheet, you can say that. So like that, we can say that about the black phosphorus is. So this is about the black phosphorus, what we required is. So this is the information about the phosphorus, what is required by us. So let us check that how the preparation of phosphorus take place. So we'll check that the preparation of phosphorus. Now we can write that the preparation of phosphorus is from phosphorus. That is how we can write that. So the preparation is from, that is phosphorite mineral, that is Ca3PO4 whole twice. That is a phosphorite mineral. Phosphorite, or from bone ash. Bone ash, you can say that. Or directly you can say that it is the bone ash which is collected from bone ash, we can say that it is collected from bone ash. Then it's treated with carbon and SO2. So we'll react this with carbon plus, we'll say that it is SO2, and it is heated at, we'll say that when it is heated, it will get converted into the calcium, that is SiO2, not SO2, it is SiO2, silicates. So it will form calcium silicates. Plus, the carbon will get converted into the carbon monoxide, and that will get converted into the carbon monoxide. And we get the phosphorus which is white phosphorus. This is the preparation of white phosphorus. Then from the white phosphorus, you can get the red phosphorus. From the red phosphorus or white phosphorus, directly you can get the black phosphorus. So that is how we can prepare the phosphorus is. So we can balance that. Calcium silicates, we can write that it is, so we can balance this as like this, we can write that. So this is how we are able to write that the white phosphorus is prepared. So this is the method for the preparation of white phosphorus. It is also, because it is heated at high temperature, so it is also called as electric furnace method. So it is also called as electric furnace method. It is also called as electric furnace method. Electric furnace method, we can say that. So that is how we are able to write that. What is the right? That is a requirement. The information about the phosphorus is required. So that is about the phosphorus. The information about the phosphorus is required by us. So this is about the black phosphorus and the red phosphorus as well as the white phosphorus is. So this is the information what we required is. Now we can say that the compounds of phosphorus we'll discuss with phosphine. So we'll check that what is the compounds of phosphorus we have to discuss is. So if we discuss the compound of phosphorus, we can discuss like this, that is, we can say that the compounds of phosphorus, we'll say that. So I'll just write that the compound of, here we've discussed about the phosphorus. So we are going to write that compounds of phosphorus. Compounds of phosphorus. So if we discuss about the compound of phosphorus, we can say that that is phosphine. Phosphine is pH 3, we know that it is. That is a compound of phosphorus. Now we have to write the preparation methods for the phosphine is. If we check the preparation method of the phosphine, generally it is formed from the hydrolysis of phosphine. And the calcium phosphide which exists in nature, by that hydrolysis of calcium phosphide or reacting the calcium phosphide with acid like HCl, then also we get that phosphine. But the lab method, already I have told you how it is. We can write that lab method also, right? So, but in most of all the reaction what we are going to discuss, unless I tell you, we are generally using that. If directly we are using the phosphorus for the reaction, then that reaction is with the white phosphorus, because it's the white phosphorus which is highly reactive. So we can say that the phosphine, we can write that directly, the preparation methods of phosphine. So if we check that the preparation methods of phosphine, let us check how it is. So we'll write that the preparation methods. So I can write that preparation methods, one we can write that by hydrolysis of phosphides. So from phosphides you can say that, from calcium phosphide. So you can say that from calcium phosphide, because calcium phosphide can be easily exist in nature or it can be formed. So calcium phosphide we can say that. So the calcium phosphide is, that is Ca3P2, that is a calcium phosphide, we used to say that. So let us check that how we can get that phosphorus from calcium phosphide. So when we react that calcium phosphide Ca3P2 with water, we are going to write that it is calcium hydroxide. What we get is, so I'll write that it is treated with water, then I get that pH 3 plus, we'll get that calcium hydroxide. So like that we are able to tell that is, this is like this. So we are able to write that the oxygen what we required is 6. So that is the balance reaction for that preparation of that is phosphine. So this is a gas which is liberated. The phosphine is a gas is liberated in the reaction. Also when calcium phosphide is treated with the HCl, then also it can liberate the phosphine gas. So we can write that either on hydrolysis or with HCl. So I can write that another method, or and also I can write that the calcium phosphate Ca3P2 when reacts with HCl, then also it will get converted into, that is pH3 plus we can write that CaCl2. So I'll get this as like this. So then also we get that from phosphine, the phosphine is liberated like that. So we can write that the preparation of phosphine by the phosphide, the calcium phosphide. Next we can write is the laboratory preparation method. So if we write that the lab preparation methods, we can write like this. So lab method, we can write that it is like this. The lab method is, we used to say that P4, the white phosphorus. When the white phosphorus is treated with NaOH plus H2O, then in that case it gets converted into, that is phosphine, pH3 plus, we used to write that it is NaH2PO2. So that is how we are able to write. Now in this case you can write that the 4 times of this, 3 times of this, then 3 times of this and 3 times of this. So we'll get that the phosphine in the laboratory, how we can prepare the phosphine in the lab. So that is the lab method for the preparation of phosphine is pH3. Now we can prepare like this from the phosphide, and also we can prepare from the laboratory. That is the commercial method from the phosphide is. Now it is non-inflammable. It does not catch fire easily, but it catches fire. It becomes flammable if it is having impurities like P2H4 or P4. That is the phosphorus which is left in that. The unreactive phosphorus which is left in that. So we'll write that phosphine is non-inflammable, but it catches fire. It becomes flammable when the impurities like P2, H4 and P4 is present in that. So we'll write that part. pH3 is non-inflammable, but it becomes flammable due to presence of impurities, right? Due to presence of impurities like we'll say that P2H4 and that is P4. So that will be the impurities which is present in that, so it becomes flammable. So that is how we can write that. It becomes flammable due to the presence of impurities, and the P4, that is in form of vapors. So obviously in form of vapors, if it is in form of vapors, then it can react, it will be reactive, highly reactive with air. So we can write that like that. So its purification is compulsory. Then we can say that. Therefore, if we write that the purification, how we can get the purification of that pH3. So the pH3 which is formed in this reaction. So the pH3 which is formed in the reaction is treated with, we can say that that is HI. So that then we can add directly that. So first we'll treat this with HI, so that we'll get that PH4I. We'll get this. So the pH phosphine which is liberated in the reaction, that will react with HI, then that HI is reacted with we'll say that pH3 treated with this HI, and that iodide which is formed, phosphonium iodide. So this is phosphonium iodide, phosphonium iodide. So iodide, when it is treated with, we'll say that that is solution of KOH. When it is treated with solution of KOH, we get that Ki plus H2O plus the pH3, the pure pH3 is liberated. So this is how we get the pure pH3 after the purification. So that is how we'll say that due to the presence of these impurities, then it should be purified by treating it with HI. Right now, HI, that will be like an acid-based reaction. HI is a very strong acid. And due to the presence of this lone pair, it can behave as alloys base. So it will show the reaction like that, and we get the reaction as. That is how we can write the purification of that, right? pH3 is. Now we can write that it explodes when it comes in contact with traces of oxidizing agent. So it will react. So it will react. We will say that. The reactions, we are going to write that. So we'll write that it explodes when it comes in contact with oxidizing agent like concentrated HNO3. These are oxidation agent. Chlorine water, bromine water. We know that chlorine water, bromine water, they are oxidizing agent. Right, etc. That is chlorine water, bromine water. So you can write like this. These are the right. We can say that etc. You can write. These are the oxidizing agent. When they are present, then it reacts with that. We know that with these it will get oxidized and convert this with HNO3. It will get converted into the H3PO4. We know that. So that is how the reaction is. Next, we can write that it is when it reacts with. We'll say that it will react slightly soluble in water, and we can get that it is slightly soluble in water. Then we can write that it is the red. We will say that the phosphine when in radiations. So phosphine pH3 in the radiations, we used to say that it gets converted into the P4, and that is red phosphorus. We used to say that. So red phosphorus plus H2 is liberated. It is converted into that red phosphorus. Then it reacts with HBr also. Then pH3 when reacts with the HBr, it gets converted into that pH, that is 4Br. It will form phosphonium bromide also. So with HBr, it forms the phosphonium bromide. So it is weakly basic, no doubt. It is weakly basic, so only react with the strong acids like HI and HBr. It reacts with that, but it is weakly basic. Then when absorbed in CuSO4 or so we can write that next is when absorbed in CuSO4 and that is you can say that HgCl2 solutions. So HgCl2 solutions. Then in that case the reactions what we have is the reaction what we get is CuSO4 when reacts with, obviously we'll write that phosphine pH3, we get that calcium phosphide, that is we'll get that it is cuprous phosphide. So Cu3P2 copper phosphates are formed. So it is cupric phosphide, and the sulfate will get converted into that as H2SO4. So it will be as it will be like this. So we get that H2SO4. So we require this as thrice. So we get this as thrice like this. So that is going to form the phosphine. So even HgCl2 solution also forms the mercuric phosphine. So let us write that HgCl2 when treated with phosphine pH3, it forms that it is the mercuric phosphide plus we'll get that HCl. So we are going to write that it is phosphide. So we'll write that this thrice. So we'll get that thrice, and we get that it is 6 HCl. So we get like this. This phosphide are formed. This is cupric phosphide. And this is mercuric phosphide. The mercuric phosphide is formed. So that is how we are able to write that, how we get the phosphide in the reaction is. So that is how we can write that the reactions of phosphide is. Now we can write that what are the uses of the phosphine is. So we can write that the uses of phosphine, generally we use that phosphine as it is a weak Lewis base, we know that, but it is used in a as a Holmes signal. That is, Holmes signal is the spontaneous combustion of phosphine. So we used to say that spontaneous combustion of phosphine is used as, to write that it is the spontaneous combustion of phosphine is used, right now, that this is a combustible gas, the impurities are present there, so it becomes combustible. So it is used, the spontaneous combustion of this will be used as Holmes signal. The Holmes signal is, that is what we used to say, that is when the containers containing the calcium carbide and the calcium phosphide, when they are right. So when the containers containing the right, that is calcium carbide, and that is calcium carbide is this, and calcium phosphide are right present under the sea water. They are that is the containers containing this is when comes in contact with the water, then on hydrolysis the phosphide gets converted to that is we'll say that pH 3, and this reacts with water to form that is P4. We used to say that the react with water to form that is the water to right now it catches fire actually, so it will catch fire, and that is react with water explosively. So this explosion is called the Holmes signal. We used to say that. So this is that Holmes signal is, and when it forms that smoke screen like that. So we say that it is also used in smoke screen. So it is also used in smoke screens. That is formation of smoke screens. That is the uses of we can say that phosphine is used in the Holmes signal, and it is also used for the preparation of that is smoke screen. So that is how we can write the uses of phosphine is. So that is about the phosphine what we have to discuss, and this is all about the phosphine what we required is. So what we have discussed about the phosphine is. So this is all about the phosphine what we required is, and that's all in this part we can say that. So this is about the phosphine what we required is. So that's all in this class. In the next class we can discuss that other compounds of phosphorus like PCl5 and PCl3, as well as we will discuss the structure of the phosphorus compounds. So that is all in this class, we can say that.